to use. Ohm's law is E is voltage, I is current, R is resistance in ohms. E is equal to I times R, and a lot of times I would hope they can manipulate that formula and get the rest of them, but they can't. Oftentimes they can't. So I actually give them the formula. Then we go over capacitance and inductance. X of C, which is the reactance and capacitance, is equal to 1 over 2 pi F of C, F being the frequency, C being the capacitance in farads. So as you can see, there's math in the electrical field. We go over power, we go over transformers, finding voltage, current, and number of turns of a transformer. When we start off with resistance. And if you don't understand, let me get these three examples. I'm on the desk over here. These are three resistors. They're separated, as you can see. You can take a meter and measure each one of them. These are the same three resistors in series. As you can see, they're connected in the end. Well, series resistance is pretty easy. The total is R1 plus R2 plus R3. They get that one easily. This is parallel. Parallel means they have the same connection at both ends. That formula is a reciprocal of the reciprocals. This is the one I have a problem with. But I always tell them in parallel, you're going to be less than the lowest one. Your final answer will always be less than the lowest one. So this is a typical lab. We have a measured or a calculated resistance, and then we have a measured resistance. Resistors, they can't write the number on the resistor. There's not enough room to write 88,000 and 88 and 3 zeros on that little resistor, so they end up doing a color code. So students learning mnemonic techniques is also important. Memory is important. And I'm going to apologize for this ahead of time, but I'm going to go ahead and Okay, so when you're reading a resistor, you pick the resistor up, and there's three color bands on it. There's actually four. The fourth one is gold or silver, and that's the tolerance. So if I saw a red, orange resistor, that's what the color band says. Red has a value of 2. Red has a value of 2. Orange has a value of 3. Well, that's not 233. The first band is a number. The second band is a number. The third band is the number of zeros. So that's 22,000 ohms. Now, you say, how do they remember this? My mama hated this. I come out of the Army and I repeated this, and she got mad because I had alcohol in it. We grew up in a Christian household. But it's bad booze rots our young gut, but vodka goes well.
Oh my. Bad booze rots our young gut, but vodka goes well.
We learned that in the Army because we all joined. We were 17, 18, and the bad. So bad is BA. So what color has a B and an A in it? That's black. Booze is BO. So what color has a B and an O in it? Brown. Red, orange, yellow, green. You have to remember this is blue. The other color with a B is blue, violet, gray, and white. So you look at the color codes and you assign it the values. And then here's the problem that the students have. If it's gold, it's plus or minus 5%. If it's silver, it's plus or minus 10%. I can tell the students, and they can do this part, and I say, okay, give me the minimum and maximum for you to be able to use that resistor within tolerance. They don't understand that part. So you either multiply by 0.95 and 1.05, or multiply by 90.9 and 1.1. So these are the lessons I have to go through the first class to get their math skills up to the point that they can build upon those math skills. So don't let anyone tell you that a student going through the electrical program, and I don't care if it's electrical welding, HVAC is the same way. You're going to have to use the math. And the English skills come in because, for instance, I make my students write a paper in all my classes, my major classes. They have to write, they have to call the inspection department, look it up in a book. I don't care what you do, but you're going to give me the top 10 reasons that contractors fail their inspections. They have to write a paper on that. If they're in a commercial class, they have to do it for a commercial job. If they're in a residential, why do they fail housing inspections? The National Electrical Code, they pick a topic of their interest, and they have to write a paper on how, if you had this job, you dream up a job, how are you going to ensure that it's done correctly by the code? Those are the 3 papers my students must write. And I'm telling you, they struggle with that because it's just, to me, it's just like you're in an English class. Okay, you're going to write it, it's going to be double spaced, Times New Roman font 12, and it's going to be APA style. They have a hard time with that. Okay, so they have to learn to communicate those. So that's the reason they do it. Because I get that question, why do we got to write a paper? You must be able to communicate. If you own your own company, you're going to have a lot of communication. Exactly. You're going to be communicating with vendors. You're going to be communicating with customers, employees, staff members. I mean, communication is key. One of the exercises I have them do is to pair up in twos. I would give them this drawing right here and these instructions, and say, I want you to wire that switch to that light, and you cannot talk. You have to tell the person how to do it, but you can't talk to them. Do anything else, you just scribble. That's a tough task. After about 10 minutes, they're all frustrated. And then you say, okay, now you can communicate. This is your instructions, you communicate. They haven't seen the instructions, you communicate to them how they are to do this. And they find out how important communication is. Because when you're told you can't talk, it becomes direly important then. It's like telling a child to be quiet. I have 3 grandkids, so I experienced that. Please sit down and be quiet, and that's the opposite of what they want to do. So once they learn how important it is to communicate, then they need to know and that is a key to completing the job. Because everything we do in here, all of our labs are timed. Now you might not be the first one done, but it's timed and then it's graded on how many mistakes did you make. So there's 2. It's just like Skills USA. You have a time limit. When that time is done, when you get done, you say you're done, you walk away. And then I will go over there and inspect it. And I will check the ground wires, I will check the connections, I will check to make sure it's done by code. So you get 2 grades. I've had students that didn't finish first but made a higher grade because they had less mistakes. Because what I tell a student, if you didn't make 100 on that lab, you failed your inspection. There's no 95 when you're on the job. You either pass the inspection or you failed. So if you didn't make 100, you would have failed an inspection. I found something wrong and it was worth 5 points. If the inspector finds it, it's just okay, you failed, call me when you get it fixed and I'll come back. Mm-hmm. And the problem with that is inspectors don't, once they find a problem, they just leave. Mm-hmm. They do not. I wish they would. I think you pay them the case.
They do pay them a lot.
They should inspect the whole job and give you a list at the end of it, everything that's wrong. But they find one thing wrong and they walk off. And then lo and behold, you fix that, they come back, that's right, and then they walk further down the hallway and they find something else wrong. And then they leave. So pay attention to detail. And the other thing is knowing how to communicate with the inspector. Now I learned that one because he has the supreme power to interpret the code ever how he wants to, which I think is wrong. So this is 2 3-ways. Okay? This is a little bit more difficult. And Dr. Miller, I'm going to apologize, but I don't think we can finish this. So what we're going to do is we're going to strip some wire. You're going to see, you're going to be able to bend it and put it around it. But I honestly don't believe we'll be able to finish this in the time allotted for everybody to do it. And I wanted to go over this. If you have questions, if you have a math class and you would like me to come speak to your math class, because the example I give my electricians is real simple. They say, I get asked the same thing. When am I going to use this? And I say, okay, you have a 4,500 watt hot water heater. What size breaker are you going to put it on? I don't know. Well, how many amps is it going to draw? Well, if I want to know current, I know my 4,500 watt hot water heater runs off 240. I take the power, divide it by 240, that gives me my current. And the code book says a breaker can only, see, I'll go over this, the code book's written by lawyers, okay? It's written by lawyers and insurance companies. The code book says that no breaker can supply more than 80% of the rated load. What does that mean? It means multiply the load by 1.25. If you multiply the current by 1.25 and you size that breaker, then that breaker is only providing 80% of its rating. See what I'm saying? The code also says, which I'll tell you this, in a residential dwelling, I say your receptacles are 12 feet apart maximum. Your receptacles can only be 12 feet apart in a residence on the wall. That's the maximum they can be. But the code says any place along the line of the wall cannot be more than 6 feet from a receptacle. And then when students go, what? How'd you get 12 feet out of that? Any place along the line of the wall cannot be more than 6 feet from a receptacle. That means if I'm standing dead in the center, I got to have a receptacle 6 feet that way, or at least one 6 feet that way, so that makes them 12 feet apart. You'd be surprised how many electricians miss that on the test. They will pick receptacles need to be 6 feet apart because they see 6 feet in the code book. This book was started in 1878 with a fire in Chicago, and it was 5 rules. The insurance company wrote the first 5 rules. It was called the National Electrical Underwriters Code because it was insurance companies writing it. And then somewhere around 1898, they had 8 or 9 insurance companies with their own code. Whoever they insured, they wrote their own code because we were just getting electrical power in the United States, so they wanted to make sure it was installed to their standard. Well, they all got together and developed a board, and they used to hire somebody to go around and inspect all these places that were getting power. The insurance company did, and the insurance company said, no, we can't do this. It's too expensive. So, believe it or not, back in the Western days, the sheriff was probably the inspector. I'm not kidding. So this book went from 5 rules in 1898 to this, what we have today. It is controlled by the Department of Insurance. Every state's Department of Insurance either adopts this code or does not adopt this code.
I got a question. You said that book is written by insurance agencies and lawyers.
Well, it sounds like it. I mean,
I'm about to say.
No, there's a code panel. The top of the book. The book has code panels, and every panel has about 10 or 12 people on it.
Okay.
Most of these are insurance people and industry.
That was my question. I was like, you didn't work in the right?
But when you read it, that's why I say communication and interpreting is very important in the electrical program. Reading this code book is like worse than reading a technical manual. It's just the way it's worded. Okay? And when they give a definition of something, That is the definition throughout this entire code book. For one of the examples, and students miss this one, is accessible and readily accessible. Now, to me, some people say that's the same thing. If I say I need, an electrical panel has to be readily accessible. That just means I don't have to move anything to get to it. I don't have to go around anything, I don't have to move anything, I don't have to jump over anything. Now, an electrical box with a connection in it has to be accessible, which means I could move that ceiling tile, there'd be a box there. I have to move something. But there's a difference in definition, so knowing how to interpret it. I think students need a whole lot of be able to read and interpret in their math, and not saying that if they're weak in these subjects, they don't need to come to the program, because I'm here all the time. I don't move from that desk during my lunch. I'm over there, and I usually have students come in, and I have 4 or 5 students eat lunch with me, and we go over stuff that they're having problems with. And so I have an office across the hallway, but Dr. Miller can tell you I haven't used it since I've been here. I sit right there at my lunch hour, and they usually come in that back door right there. So if they're willing to learn, then they can get all the help. They can get all the help in the world. I usually have some really good students that eat lunch with me too. Some top students, and they usually help some of the students that are struggling in certain areas. So, but today, I want everybody can get a. Has anybody here not stripped? Have y'all stripped wire in your previous? Okay. So this is what we call Romex. Romex. That's the trade name. The code name is NMB, which is non-metallic building cable. Okay. And we strip it with a Romex stripper, or we strip the outer sheath. And I'm sure that somebody's got a lawsuit against this company because you can put your finger in there and squeeze it. They don't make these anymore. These are about as old as I am, probably. So you see that little blade in there, you push it down, and you pull back, and it takes the outer sheath off.
Oh, wow.
Well, these are insulated. The ground is always going to be bare in building wire. And you would cut that off. And what y'all are going to get practice on today is putting the wire on a single pole switch. Okay? So these are wire strippers. They have numbers on them for different gauges of wire. This is a 14 gauge. So you put it on where 14's at, about 3/4 of an inch, and then push it off. And that little piece fall on the ground. 3/4 of an inch, push it off. Now, here's where everybody gets lost. They don't know this exists. There's a hole on each side of these wire strippers. And I have to teach students this. That is so you can bend your wire to fit nicely around the screw.
Oh, snap.
Everybody gets needle nose and tries to do it. But that fits very nicely around the screw. And you always turn it. You turn it the way, and you tighten it up, it's going to tighten the curl up. Okay, so you do the same thing with this one. And the same thing with your ground. Okay. Now, in a receptacle box, in a switch box, you bring power to your switch. This is your switch. There's a box. Your white wire gets connected. There's no longer, in some older, well, up until about 2014, you would use the white wire. It would bring power from. You would actually look in a box and you would see this, a black and a white, and the white would have black tape on it. Because people would run power to the light and they would come down with the black and go back up on this leg to power the light. It's called a switch leg. They outlawed that in 2014 because homeowners see a white wire and they think neutral. So there was too many people doing their own work in 2014. So what they said, plus there's smart devices. Let me take that back. The industry said they did it because of smart devices. So a smart device is when you use an app on your phone or something to control your lights. Well, smart devices need a neutral. They have to have their own power to run. So now in 2014, the code said every switch box must have a neutral in it that is actually a neutral. So you can hook a smart device up later. So what you'll do is you would hook in the box. Let me go get something to, let me get a wire nut. Is you would hook the neutrals together, and I'm showing you without a box because it's easier to see without the box. And you would have a black, the power coming in on one screw, and then the power going out to your light on the other screw, which is the same as this is the power coming in, this is the power going out, and your lights are wired up together. So it would look, this would be going to your light, and this would be your power coming in. And then you're breaking, this switch is breaking this hot circuit right here to cut the light off. That's what that is.
What's the copper wire?
Yeah, the copper wire is for the ground.
Oh, okay.
That's not shown on there, but you would actually hook them, twist them together and hook them to the ground wire. Okay, so and for grounds we have a special wire nut, which I'm glad they invented because back in the day they had to twist everything together. But the ground is only, it's the only time you can use this is on the ground, is a green wire nut. It has a hole in the end of it. And what that's for is to slide over the wire, and you can twist these together, and now you can take this one and it goes around the ground on your screw. You don't have to try to hook two wires around it. All grounds must be connected together. Okay, so this connects this. So this right here would go to your light fixture, and if you had a ground on it, you would ground it, and it's connected to this ground. So what I want to do, without anybody getting hurt today, don't stick your finger in here, is I'm gonna go cut some pieces. I would like for y'all to strip the Romex and then strip the ends and curl them. Because that's the hardest part about putting any device in, is the wire sticking out of the box, is getting the wire stripped. So the code says if any side of a box does not have a 6-inch opening, the wire must come out of the box 3 inches. So what I always do is this wire goes in the box, and I always just grab my hand, and if it's past my hand, I know I got enough sticking out of the box. And I always tell students, don't worry about the extra inch or so, because you're gonna need it for the ground. So if you want to stick it in the box and practice stripping it, and what you do is you reach. That's the reason these things are so long. You reach back in the box with these. Okay, so I'm gonna go get some short pieces of wire, some boxes. I've got 3 sets of wire strip. I'm pretty sure these go down to, they go down to 12. I've got 2. We'll just pass these around. Y'all can do it first. If you want to just strip the wire. Let me go cut. You go cut about 4 or 5 more pieces.
Girl, you be doing everything right here. So we can use one of these?
Yes, you can.
Do we break a slot?
You can if you want to. Yeah, all you do is, this is on the wall. These rotate, push it in. Because it's not supposed to come back out.
Okay.
Once it goes in, when you pull it out, if somebody goes to pull it out, it won't let it come out.
It won't.
Grab the wire.
Okay.
I'll cut this one off. This would normally be nailed on the wall. These rotate this way. If you see some of my speakers, that's because we're actually nailing it to the wall. You're not supposed to.
Are we in the bottom?
It won't come, if you leave this in, you put another wire beside it, see it's hard for the wire to pull back out. It's made so that it don't work out. That's good. As long as you got a handful, that's 3 inches. See, it goes to the hole right there. You gotta make sure you have pieces like in the middle.
You don't go in. Is it cut on your side? Which side is it blue?
That's why they do this. They're trying to do this.
Right.
And they end up cutting the wire.
That's it. That's it. Yes. Connect the black.
I was standing in the back there.
Oh, I'm sorry. Well, I only got 2 sets of wire strippers, so then we'll pass them back.
Gotcha.
So she's working on one side, I'm working on the other. I guess that's how it's different.
Yeah, that's fine.
You gotta get that thing up there.
Right.
Yeah, we got to put a little more pressure on it. Put this in.
I just figured that way you could just leave a box.
That's a little bit, there you go.
There's a plate.
Oh, okay.
They gotta go in.
And then pull, hold your wire, pull straight back. There you go. That did.
Oh, okay. I'll be doing some stuff around the house.
And then you pull this off and just cut that off with your cutters.
And connect the black to the black and white to the black.
Well, you wind the whites together. The black would go to your switch, then the other black would go to your light. Power coming in goes to one, and power goes out goes to the other. I want you to do it. Strip it. Yeah, strip it. So there's a number on here. If you can see it, there's a number 14 right there. It's the third. Up. So that's the one you want to put in. 1, 2, 3.
Right there.
And then pull. When you cut the wire, just push this with your thumb.
Oh, it's already cut.
Everybody, everybody cuts the wire. So you squeeze, you feel it cut, you take your finger, push it with your thumb, push the wire with your thumb. Easy. There you go. And then you can bend them.
Look at that.
This whole right.
That's what I told you. I guess that it's to keep it from
You need to turn the other way.
keep it short going. Try this one.
Yeah, there you go.
Okay.
Yeah, you want to go forward. That's all.
There you go.
And do the same thing. Here, and then bend it out. There you go. People don't know what that holds. A lot of, even a lot of electricians. The ground?
The ground.
Yep. The short way. You're right. The short way. There you go.
Okay.
There
Nice.
you go.
It's not gonna replace it. What do we do on the wire?
In the box. I'll get put wire next time.
It is right now.
Box.
Put it in a box. So it's right now it just has this on it. I want to hide it.
Yeah, I put them in a box and just put a cover on it. Is it a square box back there?
It's not a box yet.
Oh, really? Hard wire.
Right.
Yeah, I put a box.
Yeah. I have to do something. I don't want to see it.
That holds them closed so you put them in your pouch.
Feel it cut? It's cut already.
Bend your toe. Up this way. Short way. There you go. Get around the short side. There you go.
Okay, there you go. I was like, what? It's put on the end. It's a curl.
Yeah, you can keep, no, but you can keep doing this one. What you want to do is curl. You want to just do a 180.
Right.
And then you can pull it off. Just do a 180 and pull it off.
Look it up. I know. Then we'll to dishwasher.
Yep.
Make it a desk area.
Awesome.
Right now it's just this stuff. This is the sheet. Put out I see the black. waiting on
Lord,
the
have
decision.
mercy. I'm sitting here like, I know this thing's gonna
Yeah. It's like that was a ticket, so.
I ain't saying that.
What did you pick you up, bro? Very good. And I'm trying to scan the postage. Microsoft Word, this phone was separate. It's stay. I know. I'm just trying to get 15 minutes and he can get his parts in whatever it is. For So they will refer to it.